Alright, so tomorrow is your Unit 6 test. You will be asked to demonstrate your knowledge of the different types of probability models that we've studied. The first being a discrete, the second being a continuous, and the third being the binomial. So this unit covers chapters 16 and 17. Okay, but 17, again, we are excluding geometric models. Okay, so just keep that in mind. Geometric. Alright. So let's go ahead and go through the review sheet, and I will try to go a little bit slower, and if there is something that you still have a question on after I explain these, then you might want to write that down as we go along and pause the video. And then ask me tomorrow morning. So first of all, a discrete random variable has a finite or countable set of values. Okay, so it's kind of like 1, 2, 3, 4, 5, 6, whereas continuous basically can be described as a density curve. Okay, and density curves have area. Okay, because you can have those things or everything in between. Whereas discrete, you can only have those things that are specified. 1, 2, 3, nothing in between. Okay? So the probabilities themselves should be between 0 and 1, and then all the probabilities have to add up to 1. If you are asked to verify that it is a discrete random variable, you must show that all of those probabilities in the table add up to 1. Okay? A normal curve is just basically one example of a continuous random variable. Okay, we're going to be looking at, alright, my pen's not writing very well right now, but in any case, okay, it's just one type, and we're going to be looking at a couple of different types. Alright, number 3, how does one find, that is mu sub x, of a discrete random variable? Okay? So this is when you have a table of values. We'll be looking at an example of that a little bit later in the packet as well. But you are basically going to take the first x value and you are going to multiply it by its probability. And then you are going to add the next x value and multiply by its probability. And then the third x value, and so forth. Okay? The formula that you're going to have on your review sheet is going to look like this. It's going to have your sum notation, and then it's going to say x sub I, p sub I. So basically I'm going to add up, you're going to sum all of the x values times their probabilities. Okay? Same thing for variance. Variance, you're going to do the same thing. You are going to see the sum notation, but instead of this formula, you will see the x value, sub I, minus the mean of x squared times its probability, or p sub I. Okay? So you would take the first x value, subtract the mean, square it, and multiply it by its probability. Add to that the second x value, subtract the mean, square it, times the probability. Okay? You have to show all of this work. Show all work. Okay? If you think it, write it. If you put it in your calculator, write it. Okay? That's kind of the rule of thumb. You want to make sure that you have everything shown so that if there's any question, we can look and see if your thinking was correct. And then that little symbol here, that little sigma, that is standard deviation. You find that by taking the square root of the variance. So the standard deviation of x is equal to the variance of x and the square root of that. Okay? Alright, moving on. You have to know these. These are not given to you. Okay? Only what is on that yellow sheet is given to you. These are not given. Memorize them. Okay? Especially this one, which so many of you seem to forget, and this one. Those are kind of unusual rules. Okay, when do we use PDF instead of CDF when calculating probabilities? PDFs are when you have equal to, so the probability of X equal to something. CDF is when you have the probability of X is less than or equal to. That's what it's going to calculate. Okay? Now, if you need to find less than, greater than, equal to, you will use the CDF function. Just with less than, you're going to include one less. With greater than, you're going to do the complement. And then with greater than equal to, you're going to do the complement of one less. Okay? So just be careful. You are going to use the CDF when you have any inequality. It's just going to depend on what value goes in there for the K value. Okay? And this is, again, we studied these mainly with binom, the difference between PDF and CDF. And again, when you put those in, you always want to do N, comma P, comma K, where N is your number of values, or the number of things you're finding or taking, P is your probability, and K is your value of the probability. So whatever you have right here, this is going to be your K value. Okay? What is the mean and standard deviation of binomial distribution? You are given these. Okay? The mean is going to be equal to N times P. The standard deviation is going to be equal to the square root of N times P times the complement of the probability. A little ahead of myself. 1 minus the probability. Okay? And again, you're given those. Alright, number 6. An opinion poll asks a simple random sample of adults, do you exercise? The proportion of adults that answers yes is calculated. The answer to this question is considered a continuous random variable that is normal. Okay, whenever you see normal, you should think bell curve. Okay, here's your bell curve. Okay, in the middle goes your mean. Okay, if it's a standard normal curve, your mean would be 0, which is what we're going to have to do to this problem. We will have to standardize it. So whenever you see this notation, this means a normal model with a mean of and a standard deviation of. Okay? So, again, this 0.3 goes in the center. Is this a standard normal model? No. Remember, in a standard normal model, your mean is 0. So this is not a z-score. Please don't think that. Then you go standard deviations of 0.118. So if I add 0.118, I would get 0.418. And then so forth. Okay? And then subtract 0.118, you would go the other way and subtract 0.118. So that would be 0.2, let's see, 282, I think it is. All right? So this is not a normal model. I have to normalize. I have to standardize, get a z-score for that value. So I have to translate this, well, actually, this is what I'm actually looking for. But I have to use the mean in my translation. So I'm actually trying to find the probability that more than x is greater than 0.35 or 35%. That's what I'm looking for. So I have to standardize this. This is not a z-score. Not a z-score. Okay? So I'm going to take the value, 0.35, subtract the mean, 0.3, divide by the standard deviation. This is your conversion formula to get the z-score. So when you do that, you get 0.424. Okay? If you want to actually use percentages here, that's fine. You could do 35 minus 30 divided by 11.8. Whatever. You're going to get the same answer. Okay? So now that you have your z-score, now you can put it in your calculator. So you're going to do normal CDF. This is a normal model. Notice I didn't use binom. I used normal CDF. The first number is going to be what you're going. So remember, I'm looking for 35% and above. So 35% is going to be about here, and I want everything above. So my first interval, my interval starts at my z-score of 0.424. And then it goes up to infinity, or just a really large number, 99, 1,000, whatever you want to use. And when you put that into your calculator, you will get the probability is equal to 0.336. Okay? Again, don't forget to look and see what you're rounding to. If it says 2, round to 2. Standard for these is usually 4, but anywhere between 2 and 4 is acceptable if it's not stated. Alright, let's look at the next one. Probably just do 7, and then I'm going to be making another video. Number 7, studies of social mobility in England can be summarized in the language of random variables. Social classes are numbered from 1 to 5. Take the random variable x to be the class of random chosen son of a lower class father. The distribution of x is followed. Okay? So, again, is this a legitimate discrete random variable? So how do you check that? Well, first of all, are all of my probabilities between 0 and 1? Yes. Okay, so all probabilities between 0 and 1. And then you have to check and make sure that all of these add up to 1. So is 0.48 plus 0.38 plus 0.08 plus 0.05 plus 0.01, does it equal 1? And you can plug those in that they do. Okay. What is the probability that x is less than 3? So do I include 3? No. I just want 2 and 1. So I'm just going to add 0.48 plus 0.38, and I will get 0.86. Write the event a son of a lower class father reaches one of the two highest classes. So, one of the two highest classes is going to be either class 4 or class 5. Okay? You can write this a couple of different ways. You can say the probability of 4 or 5. You could also say the probability of x is greater than 3. You could also say the probability that x is greater than or equal to 4. All of those are acceptable. In any case, you're just really adding those two probabilities together, and you get 0.06. D, a father's social class is class 1. Right event, the son of lower class father reaches a class higher than his father's. So if he's class 1, what is the probability of all of these? So again, the probability that x is greater than 1. That is easily calculated by 1 minus the probability that x is equal to 1. So you could do that too. Okay? Any of those, you're really just adding together everything else in the table, or you're taking the complement of 0.48 and you get 0.52. Expected value, that is mu. So mu sub x equals 1 times 0.48 plus 2 times 0.38 plus 3 times 0.08 plus 4 times 0.05 plus 5 times 0.01. Put all that in your calculator and you will get 1.73. That is then used in the calculation of the standard deviation, which again, standard deviation is the square root of the variance. So first you have to find variance. To do that, you take the x value, subtract the mean, square it, times the probability. The next x value plus the next x value minus the mean, square it, times its probability. Once you do all of that with all of those values, you take the square root, and when you do that, you would get 0.77, and the square root of 0.777 is 0.881. Okay? Alright, look for another video with the rest of the review sheet.